Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we are starting today is Sequence and Series, which is chapter 9 of class 11th Mathematics. And today is the turn of exercise 9.1. This is the beginning exercise and very simple questions are asked in this exercise because you just talk about what is AN in general for a sequence, let's say, and questions are directly based on that. Different formulae are given for AN, and on the basis of that you can write a sequence and form a series. Right? That's all that is covered over here. So along with the questions we'll be seeing, there are not many concepts, but whatever are the concepts we'll be seeing along with the questions. Right? Moving on, the first question says, okay, what does the first question say? Write the first 5 terms of each of the sequences in exercises 1 to 6 whose nth terms are this and this. Okay, so AN is given n times n plus 2. And you are supposed to write the first 5 terms. So A1 will be 1 times, this is 1 plus 2 which is 3. A2 will be 2 times 4. A3 will be 3 times 3 plus 2, 5. A4 will be 4 times 6. A5 will be 5 times 7. Now what are these values? This is 3, this is 8. This here is 15, this here is 24 and this is 35. So if you want to write the terms of the sequence 3, 8, 15, 24, 35. These will be the terms of the sequence. That's my required answer for this question. Just very simple, right? In second question we have AN is equal to n upon n plus 1, right? And once again we are supposed to write the first 5 terms. So let's focus on writing the first 5 terms. First 5 terms will be A1, comma A2, A3, comma A4, comma A5. What is A1 equal to? A1 is 1 upon 1 plus 1. This is 2 upon 2 plus 1. 3 upon 3 plus 1. 4 upon 4 plus 1. 5 upon 5 plus 1. Now what is this equal to? This is 1 by 2. This is 2 by 3. This is 3 by 4, 4 by 5, 5 by 6. That's my required answer for this particular question. In the third, we have AN equals 2 power n. The first 5 terms can be written easily. Let me write the terms directly. Instead of n, we have 1 for the first term, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. These are the first 5 terms. What is this? This is 2. This is 4, this is 8, 16 and this is 2 power 5, not 25, this is 2 power 5 which is equal to 32. That's my required answer, first 5 terms of this series. That's all. In the fourth question we have AN equals 2n minus 3 upon 6. Okay. What will be the value of A1, A2, A3, A4 and A5? So A1 will be 2 minus 3 upon 6. A2 will be 2 into 2, 4 minus 3 by 6. This will be 2 into 3 which is 6 minus 3 upon 6. This will be 2 into 4, 8 minus 3 upon 6. This will be 5 times 2, 10 minus 3 upon 6. What is this? This is minus 1 by 6. This is 1 by 6. This is 3 by 6, this is 5 by 6 and this here is 7 by 6. Those are the first 5 terms of this series as you can see over here. In the fifth question we have AN equals minus 1 power n minus 1 into 5 power n plus 1. So A1, A2, A3, A4, A5. Let's focus on these terms. A1 will be minus 1 power 1 minus 1, 0, 5 power 2. This is what you'll have. A2 will be minus 1 power 1, 5 power 3. A3 will be minus 1 power, A3. This is minus 1 power 3 minus 1 which is 2, 5 power 3 plus 1 which is 4. A4 will be minus 1 power 3, 5 power 5. A5 will be minus 1 power 4, 5 power 6. This is what you will have. Is that okay? Yes. What is this? Minus 1 power 0 is okay. This is 25. This is minus 125. Minus 1 square is plus, this is 625. 5 power 4 is 625. Then minus 1 power 3 is okay. 5 power 5. What is that? You multiply this with 5, and that gives me 3125. There is an extra minus over there, right? 5 power 5 will be this. Okay, and what about this? Minus 1 power 4, this will be plus, and 5 power 6 will be, okay, this multiplied by 5. Now what is that? 125 multiplied by 5 will be 625, and 5 times 3 is 15. This is 15625. That's the correct answer, and those are the first 5 terms of this series, as you can see over here. For 6th question, we have an equals n times n square plus 5 upon 4. So a1, a2, a3, a4, a5 can be found easily by substituting n equal to 1, 2, 3, 4 and 5 respectively. So this becomes 1 times 1 square plus 5 upon 4. This is 2 times 2 square plus 5 upon 4. This is 3 times 3 square plus 5 upon 4. A4 will be 4 times 4 square plus 5 upon 4. And A5 will be 5 times 5 square plus 5 upon 4. This is what you will have. Simplifying this value, this is 5 plus 1, 6 upon 4, which is 3 by 2. 4 plus 5, that is 9 upon 4 into 2 will be 9 by 2. 9 plus 5 is 14 by 4 will be 7. 14 by 4 will be 7 by 2 into 3 will be 21 by 2. This is 9 here. What is this? 4 and 4 goes away. This is 4 square, 16 plus 5, which is 21. What about this one? This is 5 squared. 25 plus 5 is 30 upon 4, 15 upon 2. 15 times 5 is 75 upon 2. This is my answer for this 6th question, as you can see over here. Question number 7 says, find the indicated terms in each of the sequences in exercises 7 to 10 whose nth terms are given by this and this. Okay. So an is 4n minus 3. And now we are not supposed to find the first few terms. We are supposed to find very specific terms, that is, one is A17, the other is A24. What is A17? This is 4 times 17 minus 3. What is that equal to? This is 17 times 4 is 68 minus 3 will be 65. What is A24? This is 4 times 24 minus 3. That 96 minus 3 will be 93. That's my required answer for this question, as you can see over here. In the 8th question, we have an equals n square upon 2 power n. Okay, and we need A7. So A7 will be 7 square upon 2 power 7. What is that? 49 upon 2 power 5 is 32, 64 and 128 is what I will get. That's my required answer for this question, 8th. In the 9th question, you need A9. Okay, and A9 will be equal to minus 1 power 9 minus 1 times 9 power 3. This is minus 1 power 8, which is plus 1, and 9 power 3 is 7 to 9. That's my required answer for this 9th question. In the 10th question, we have an equals n times n minus 2 upon n plus 3, and what do we need? We need A20. So A20 will be 20 times 20 minus 2, which is 18, upon 20 plus 3, which is 23. What is that? This is 360 upon 23. That's my required answer for this 10th question. In the 11th question, the question says, write the first 5 terms of each of the sequences in exercises 11 to 13 and obtain the corresponding series. Okay, corresponding series would be, you have a plus sign between those few terms. Okay, plus or minus sign for that matter, if so is the case. So A1 is given as 3, and there is a formula which says an will be 3 times an minus 1 plus 2 for n greater than 1. Okay, n greater than 1, right? So A1 is already known. A2 will be equal to what? A2 will be 3 times A1 plus 2. Applying this formula, A2 will be this. A3 will be 3 times A2 3 times A2 plus 2. A4 will be 3 times A3 plus 2. A5 will be 3 times A4 plus 2. Simply applying this formula over here. Okay. A2 will be 3 times A1, which is 3 times 3 plus 2. What is that? 3 times 3 is 9 plus 2 is 11. A2 is 11 therefore. A3 is 3 times A2 plus this, that is 3 times 11 plus 2. What is that? 35. This is 3 times 35 plus 2. What is that? 3 times 35 will be 105 plus 2, which is 107. This is 3 times 107 plus 2. What is that? 321 plus 2 is 323. So the first 5 terms have been found and the corresponding series will be 3 plus 11 plus 35 plus 107 plus 353. That's the corresponding series. That's my required answer. This and this. Right? That's all that you have in this 11th question. In question 12th, we have A1 equals minus 1 and then there's a recursive relation again given over here. An is this. So A1, let's begin with this minus 1 and we know that An will be An minus 1 upon n for n greater than equal to 2. Okay, if this relation is given, can I find A2? Yes, A2 will be An minus 1, which is A1 upon 1 upon 2. If n is 2, A2 will be A1 upon 2. A3 will be A2 upon 3. A4 will be A3 upon 4. A5 will be A4 upon 5. This is what you'll have. Is that okay? Yes. So A2 which is A1 upon 2, that becomes minus 1 upon 2. What about this? A2 is minus 1 upon 2 upon 3. This is minus 1 upon 6. A3 is minus 1 upon 6 upon 4, minus 1 upon 24. Minus 1 upon 24 upon 5. What is that? Minus 1 upon 120. That's my required answer for this. These terms of the series, that's what you can say. Terms of the sequence. What about the sequence itself? The series itself. What about the series? The corresponding series that you will get will be starting from minus 1 plus, there's a minus 1 by 2. Okay. So let's write a minus 1 by 2 over there. Then you have minus 1 by 6. Then you have minus 1 by 24. And further you have minus 1 by 120. That's my required series over here. The terms and the corresponding series. That's what you have in this question. In 13th question, we have A1 equals A2 equals 2. Okay. And then there's another thing given. An equals to An minus 1 for n greater than 2. A1 equals A2 equals 2. And you are given that An will be An minus 1 for n greater than 2. So for n greater than 2, we'll look at A3 first. What is A3 equal to? That is A2 minus 1. A4 will be equal to A3 minus 1. A5 will be equal to A4 minus 1. This is what you'll have. And what is A2? A2 is 2. This is 2 minus 1, which is 1. A4 is A3 minus 1. This is 1 minus 1, which is 0. A4 minus 1, which is 0 minus 1, which is minus 1. This is what you observe, right? So corresponding terms have been found. Terms of the sequence will be 2, 2, 1, 0, minus 1. The corresponding series will be 2 plus 2 plus 1 plus 0 minus 1, and that's my required answer for this 13th question, as you can see over here. In the 14th question, we are given the Fibonacci sequence is defined by 1 equals A1 equals A2, and then you take sum of two consecutive terms to get the next term, right? That's the Fibonacci sequence. It is a very famous sequence. A1 is equal to A2 is equal to 1, and then you have An is equal to An minus 1, An minus 2. right? This is what you have. What does that imply? A1, A2, A3, A4, A5, if these are the terms of the sequence, A1 and A2 are 1 and 1. A3 will be A2 plus A1, sum of these two. Then A4 will be sum of the previous two terms, which is 3. A5 will be sum of these two terms, which is 5. And if you continue further, the next term will be 8, and 8 plus 5 will be the next term. Then continuously adding them will give you the sequence. The Fibonacci sequence is defined by this. Find an plus 1 upon an for n equals to 1, 2, 3, 4, 5. Okay. So for 5, this is A6. So at least write up till A6. 5 plus 3 is 8. Over here, this is A6 for us. Okay. If you want, you can find A7, A8 as well, right? The sequence looks like this. 8 plus 5 is 13. 13 plus 8 is 21, and so on and so forth, right? This is what you get. This is the sequence. But the person is not actually interested in the sequence. The person is interested in the ratio of these terms. And there's a special relation about that ratio. I'll explain that also. Over here, Fibonacci sequence is defined by this. And what do we need? Ratio of an plus 1 upon an. This ratio. So first of all, let's take n equals 1. This tells me A2 upon A1 is equal to 1 upon 1, which is 1. Then you need A3 upon A2 is equal to, this is for n equals 1. For n equals 2, this is what you get. A3 upon A2, which is 2 upon 1, which is 2. N equals 3. This is A4 upon A3, and what is that equal to? That's 3 upon 2. What is that? A4 upon A3 is 1.5. N equals 4 implies A5 upon A4 is equal to 5 upon 3. This is what you get. N equals 5. This tells me A6 upon A5 is equal to 8 upon 5. By the way, what is this equal to? 5 by 3. This is 1.666 and dot dot dot. This is 8 upon 5 is 1.6. This is what you are getting. Is it okay? Yes. Can you take a look at this particular value? For n equal to 5, you have A6 upon A5, which is equal to 1.6. These are the values of an plus 1 upon an for n equals to 1, 2, 3, 4 and 5, as you can see over here. Now the special thing about this particular ratio of two consecutive terms of this sequence is that the ratio actually tends to a particular value, when the value of n becomes sufficiently large. When the value of n becomes sufficiently large, this ratio tends to a particular value over here. What is that particular value? Where are we? Okay. What's that particular value? So that particular value that I'm talking about is approximately, it is 1.618 something. This is, and this is a particular value. This particular value is actually called the golden ratio. It's called the golden ratio, and it is found at many places in nature in general, and it is also related to this Fibonacci sequence, as we have seen, right? One important concept and one important mathematical concept, actually not useful for NCERT, but then this particular ratio directly relates to this particular thing over here. Okay. And with this, we come to the conclusion of this exercise from the chapter Sequence and Series. Till the next lecture, all the best.